Hey, so I decided that for this AMI, instead of just giving you a ton of stuff to read, I would record these little tiny lectures. Tiny, they're gonna be like between 5 and 10 minutes ish. That way, like, I know that it helps a lot of times to hear the stuff said as opposed to it just being, in words. So that's why I'm doing this. Also, I realize that a lot of you have never actually been this close to me before, so this is what my face looks like. I don't really know where to look because there's like the camera and then there's my face that's moving and talking, and that's weird. Um, Sorry if I like am looking different places. I feel like a weird YouTuber. I have my husband's like headset here to record the audio on. I refuse to put it on because if I did, I think I would have to start saying things like "What's up, gamers?" But whatever. So, I have talked for an actual minute about nothing. Let's get into what we're actually going to be talking about today. Well, before we do that, my intent with these is that you can kind of follow along with me and take notes. And when we come back to school, we will have an open note quiz over the stuff that I've talked about here, which you will be able to use your notes on, but only if they're yours and they're handwritten and, showing me that you actually are doing stuff over this AMI. So, let's get started. So I decided for this weird kind of AMI break thingy that we would just start talking about the kind of things that live on the planet with us. So here I have kind of a flow chart, a family tree showing all of the different things that live on this planet with us. We actually are in this category right here. We are vertebrates, which means that we have a backbone. So we're going to start up here with prokaryotes, then we'll move into eukaryotes. We'll talk about protists, funguses, and plants, and then hopefully when we come back to school, at the end of the year, we'll be able to get into different animals and talk about, how cool they are and the difference between reptiles and fish and all that cool stuff, which is the stuff that a lot of people get into biology to talk about. But before we even get into the different kinds of organisms, we need to talk about what it means to be alive. Now, this is just going to be very brief because we did do this at the beginning of the school year. And so I'm just going to be kind of reviewing what we talked about then. So, what does it mean to be alive? Well, all living things are made of cells. Okay, we have talked so much about cells. If you are alive, congratulations, you have cells. We do not recognize things that are not cells as being alive. So these are kind of things that we look for too when we go to other planets to look for aliens and stuff, is if we can't find cells there, we know that there's probably not living things there. Sorry for the weird jump cut. Also, my light is different because my dog ran underneath my feet and yanked one of my lights off of the wall, which was cool. So, yeah. Anyway, all living things reproduce. All living things have babies. We talked in the meiosis unit about how that can be sexual reproduction, like humans and other animals and mammals and whatever, like humans do, where you are taking two different individuals and combining their DNA to create a new individual. Or it can be asexual, like our individual cells are doing with mitosis, where one cell is turning into multiple two clones. Okay. I have to go click back on the slide. Okay, all living things grow and change. You look different now than you did when you were born, and you will look different the day you die. You just are going to grow, and that goes into this one. All living things use energy. This one right here. A lot of our energy is going into growing. You have to eat. You use that food to fuel your growth and change and development, and then you poop it out. Things that are not alive don't use energy, like rocks don't eat. Okay. And then the final two kind of go together. Living things respond to their environment, and living things evolve. Okay. So you are an active participant in the world that you live in, and you are changing and, making changes and, adapting and fitting better into your environment. So Those are categories of all living things. But before we even get into something that's alive, I want to talk about something that's not alive and something that is very topical with what we are doing right now. So let's talk about viruses. This is a picture of a virus right here. Not all of them look like this. I think that these are probably the coolest looking ones though. Viruses are weird because they are not alive, okay? They do not possess all of the qualities of a living being. They are not made of cells. They're too small. This right here, this green thingy that he's standing on top of, that's a cell. He's way too small. He is not cellular, so he's not alive. They also don't grow. They are this shape when they are created, and they will remain this shape until they are murdered by other viruses or, your immune system. Viruses also do not use energy. They don't eat. They don't have a digestive tract. They don't poop. They don't, do any of the thermodynamics with like heat and stuff. So they don't use any energy. And they can't reproduce on their own. So we're going to talk about that here in a minute, but they can't have babies. This guy's not going to go find a lady virus and have a baby with her. He's not even going to do asexual reproduction. They don't have babies on their own, and that's the catch, and we'll talk about that in just a second. What a virus is it's basically just some DNA, which is kept up in this weird crystal looking thing up here. And then this is all just kind of some protein that's wrapped around it and has some functions. So I've got pictures here of two different viruses. This is the one that is concerning for us, but these are the ones that are kind of more cool looking. So we'll talk a little bit about both. The first thing you'll notice on these viruses is this like structure here. I think this is not good at geometry, some sort of three-dimensional shape. And it is called the capsid, and it is there to protect the DNA. So inside of here, you can kind of see it looks like red springs, and over here it's these red squiggles. That's the virus's DNA or RNA. And this capsid kind of functions like a nucleus, I guess, where it protects the DNA. Then you've also got these spikes. Okay, now this guy's got lots of spikes. This guy doesn't really have spikes, and it's because this guy has these weird leg thingies. But the spikes are not for defense. They are more to help them attach on and stick to things that they want to attack. Some viruses have spikes that like hook at the end, and it helps them snatch onto things easier so that they can, wiggle their way in and infect you. And then finally, inside of this capsid, they've got their DNA. Now, some viruses, like this guy right here, have a neck and a tail and sometimes legs, which you can kind of see down here. And those guys are objectively cooler looking. Like, these are cooler than that. But these guys don't really bother humans, so there's not, we're not going to spend too much time talking about them. So I do want to spend a lot of time talking about how viruses have babies, though, because it is nuts, because they do not reproduce on their own. That's one of the reasons why they're not alive. So the first thing that a virus is going to do is it's going to attach into a host, like you. It's going to, get in your nose, get in your mouth, in your eyes, anywhere that you have like a mucus membrane, and it's going to get inside of your body. It is then going to get into your cells and make its way to the nucleus, where it will inject its DNA into the nucleus of your cell. And what it is basically doing, it is hijacking your cells. Okay, and you can see in this little animation that keeps playing, let me wait for it to get there. So that's his DNA, and it's going to go in and it's going to inject itself into the host's DNA. And basically what's going to happen is it is going to kick the cell into overdrive so that the cell does tons of protein synthesis, but only on this viral protein. And you make the cell make new viruses. Now remember, they're not alive. They can't do this on their own, so they have to have you do it for them. And that's one of the reasons why we can't, it's hard to fix you if you get a virus, is because it's literally your cells are broken and now turned into virus factories. It's also one of the reasons why viruses can get so bad. So, There are three basic ways to classify a virus. Uh, Viruses are classified by who they attack, the kind of organisms that they are, targeting, the kind of genetic information that they have inside of them, and what they look like. And we're only going to talk about two types of viruses. The first is this. It's called a bacteriophage. And they're actually not a problem for humans because they attack bacteria. It's in the name. Inside their capsids, they have DNA all twisted up in here, and they look like these weird little spider guys. I'm pretty sure also that these were on Jimmy Neutron, and so a lot of people know what these look like. But yeah, it's creepy because their legs actually do work like spiders, and they use them to help inject their DNA into the cells, and it's really gross. But they don't attack humans, so you don't really have to worry about them. These are the ones that we do have to worry about. So these are called retroviruses, and they attack eukaryotes like us. So these are going to be flus and, immunodeficient, like HIV, stuff like that. What's the one where you get a cold sore? Whatever that one is, I can't remember. And one of the reasons that they're so successful is that inside of their capsid, they have RNA and not DNA. So we talked about how, your body tries really hard to keep the DNA in the nucleus and the RNA goes outside of the nucleus. And so these guys have learned that and changed over to having RNA so that it's easier for them to infect us. And they look kind of like these little spike ball thingies. And again, these spikes are there to help them attach to us and stick in and make us sick. So I want to talk about some things that you can do for a virus, and we're getting a little low on time here, so I'm going to kind of try and not waste y'all's time too much. But if you get sick with a virus and you go to the doctor, they're not going to be able to kill it, okay? Because it's not alive. You can't kill it. It's not alive. But what you can do, there are some medicines that you can be prescribed, like Tamiflu, that they're not hurting the virus, they're not killing the virus, but they are slowing down its ability to reproduce, which kind of gives your body a chance to get back in and fight the virus away easier as opposed to being overwhelmed. So yeah, but probably the best way to deal with a virus is preventative. It is to do vaccines. So a vaccine is basically they take a weak virus that is non-active, that has lost its ability to reproduce, they have made it that way, and they will inject it into your body so that your immune system can fight it very easily. It's not a big deal for your immune system to knock it out. And what that does is it builds up your natural immunity to that virus so that you won't get sick with it. Now, I hear a lot of people all the time talk about how they got the flu virus and then they got the flu. Or the flu vaccine and then they got the flu. And that may be true because there's 100 different types of flus and they can only vaccinate you for 5. So you probably just got a flu that you didn't get vaccinated for. They usually take the worst ones and vaccinate people for those. But yeah, you probably will feel like crap for a few days after you get your flu shot because they made you sick so that you could not get super sick later. So that is our little lecture on viruses. Tomorrow we will come back and talk about prokaryotes. Up here you have a small assignment that goes with this lecture. Make sure that you took notes so that when we come back you can take a quiz and use those notes to help you. I hope you guys are resting and using this break wisely, and see you tomorrow. Bye.